For our next session this morning, we have Claudio Becker Foss, who will be talking about interoperability between AES67 and ST2110-30. The formats are very similar, but there's some subtle differences you need to be aware of, and I'm looking forward to hearing about this. Thank you very much.
Thank you. Good morning, everybody. AES67 and ST2110-30 are both standards for audio transmission in over IP. And while those are standards, the actual implementation in the devices might differ from manufacturer to manufacturer. So I would like to go through a couple of things that you should keep in mind. You should look out for when you set up an AES67 system between different brands, and what peculiarities or pitfalls can arise when putting such systems together. So I will give you a brief recap of AES67 and ST2110, just very quickly, because Dominic already talked quite a bit about that. Then we take a closer look into the mandatory and extended sets of AES67. So what is actually mandatory, what needs to be in a device to claim that it's AES67 compliant, what is an extra that might not be available in certain implementations. Then we take a look at what information is actually needed to set up an AES67 stream between certain units. I will show you a couple of tools that help to set up streams for troubleshooting in the system. And finally, I will take a closer look at the combination of AES67 and Dante devices in AES67 mode, which have slight differences where you have to work around, and I will point out what things that will be. So AES67 is an interoperability standard for media over IP, and the goal of this standard was to find a common ground to exchange audio or media between devices of different brands that already had proprietary IP implementations. So those devices might have had already audio over IP in place, but they were not talking to each other. And the AES went and came up with a standard to provide exchange on the common ground between those devices, audio back and forth. That means that not scope of the standard is discovery and management of all this. So setting up streams, organizing your streams, finding devices on the network, that's not part of AES67, and as such, AES67 is not a complete full-fledged solution for a media system. It's just providing the possibility to exchange audio back and forth between devices. ST2110 is a standard suite that consists of certain subsets. -10 is talking about system timing and synchronization, so it gives the scope how to synchronize my whole system in the network, while the -20 and -21 parts are covering video transmission. -30 and -31 are covering the audio transmission, where -30 actually refers to AES67. -40 covers ancillary data transmission, and there might be other subsets coming up in the future depending on what the industry needs. So -30 covers the audio part of ST2110. It uses synchronization with PTP-v2, and as such it allows to synchronize audio with video on the same network, although both take different paths, maybe different processing, different devices that handle the data, but in the end you can join it synchronized on a sample basis on the receiving side. It refers to AES67 in its latest revision from 2018. Last year the revision of AES67 has been published, and this audio format is to be used for -30 streams, although a few constraints apply. And there's a white paper actually on the AIMS website put together by Andreas Hildebrand, which is pointing out all these constraints and also the commonalities between those two standards. And it's a helpful document to really spot out the certain differences between 2110 and AES67 in detail. So I'm going to do a quick recap of AES67 to just give a quick overview what the standard mandates, and then have a look what actually has been implemented by the manufacturers. So mandatory for AES67 is a sample rate of 48 kilohertz, a packet time of 1 millisecond, and synchronization of PTP v2. Then we have IGMP v2 on the network to organize the multicast traffic. Actually, ST2110 uses v3, but IGMP has an automatic fallback, so if there's a v2 device on the network, the whole network will fall back to IGMP v2 anyway. So in AES67, actually v2 is mandatory. It gives DSCP markings for quality of service. So the clock packets for PTP are supposed to be marked with EF, and the media is supposed to be marked with AF41 to make sure that the switches handle clock and media with different priorities, with different queues, so that the synchronization is stable. It has the fastest path through the network, while media is, of course, with high priority, and then anything else on the network is just with best effort whenever it's time on the switch to put the data through. The audio encoding, which is also mandatory, is 16 and 24-bit. The channel count is from 1 to 8 channels per stream, and multicast and unicast streaming is also mandatory in AES67. So a device should allow to set up multicast streams, but also unicast streams between two devices. And an SDP of some sort needs to be provided to describe the stream parameters. The only protocol for stream connection management that is mandatory also, and which is mentioned in AES67, is SIP, which is particularly used for unicast. So if you want to do unicast with AES67, you are supposed to use the SIP protocol to set this up. That was basically what's written in the standard. So if you buy an AES67 device today, you should normally expect that all this is in there, working and provided, because if you claim that you are AES67 compliant, you should support this. Beyond that, there's a lot of other stuff. Of course, you can also do different sample rates. You can go for 96 kilohertz, you can go for 44.1. The standard provides information how you should do that if you want to do it. And thank you. Tweaking the sound system a bit. It also allows for other packet times, because 1 millisecond, for instance, for live sound is quite a lot. And if it sums up through the system, it's already not really usable for live sound applications. So you might want to have streams with very low delay, very low latency, which is possible also with 125 microseconds packet time, for instance. But you can also go up to 4 milliseconds, for instance, if you use it for WAN applications. So that, like this? Oh, okay. Then you can also use, of course, more than 8 audio channels per stream. So with a lower packet time, like 125 microseconds, you can go up to 64 channels, for instance. You may use AGMP v3, and it's not in the scope of the standard, as I said, but you can, of course, put on top of AES67 discovery protocols like RTSP, Bonjour, SAP, to make it more comfortable for the user to set AES67 streams up and configure your system. So here's a quick overview of different packet times compared with sampling rates and the number of channels you can achieve. For instance, with 125 microseconds, you can go up to 80 channels. This one here is the 1 millisecond packet time, which is mandatory, which allows theoretically up to 10 channels, but the mandatory part actually defines 8 channels per stream. So that would be sufficient to claim that you are AES67 compliant. So what do I actually need? What information do I need to set up my stream? This is an SDP file which looks quite messy on the first glance, but it contains basically all information that is needed to set up a stream, and fortunately I only use a certain subset of this. So first off, I need the multicast IP address, which is written in the C line here. I see this stream is sent to 239.69.0.1, and that is where I can receive my stream data. Then I need the destination port, which is 5004 in this case. It's a standard port, but it could be something different. So if you come to a place and you have another device that streams something out, you might want to check if it actually uses the destination port 5004 or maybe something different. You can maybe look this up in the SDP file, or you can see it in this user interface of the device. It depends how the manufacturer implemented that. The encoding here is 24 bits. You can see this here in the RTP map line, 24-bit, 48 kilohertz, 8 channels. So this information is written here. And the payload ID is 97. That's also a crucial information because this is a dynamic payload type. It could be 98, could be 99, 100, whatever. So there are some devices that refuse to connect to the stream in case the payload ID does not match. So if everything's right in your setup, IP address, destination ports, that's all fine, and still you have no sound, you should check the payload ID because maybe that's not matching. And then, although everything else is fine, you will have no connection on that stream. Finally, we have the frame count value, which is 48, meaning it's a packet time with 48 samples per packet, so 1 millisecond packet time. That's a standard AES67 stream. Now, how do I get this into my device? The standard does not say or tell you how, or to tell the implementer how it should be done. The most basic way would be to do it manually and just type the numbers in the user interface to set up the stream, to configure it. You could use RTSP, for instance, if it's implemented in the device. Ravenna uses this, for instance. I could use sub announcements, where the SDP file is distributed on the network or published on the network. That is used by Dante. Side note is that Dante controller does actually not provide means to manually enter streaming data. So if you want to set up something with Dante, you have to use sub, and to make it work with sub somehow. I will show you a tool in a second that will help you with that. And here we go. In the future, it will, of course, also be possible to use NMOS, which you can see over there in the tech stack demo. Devices using NMOS to set up streams to discover devices on the network. So this is also possible. It works very well with 2110 and also AES67. So if you need a sub-announcement, you could use a tool from ALC Networks, which is freely available. You can check out ravennanetwork.com for this. You can download it for free, and it can read RTSP announcements on the network and output sub-announcements. So it's just transferred, and by that allows, for instance, to bridge Ravenna devices, the streams that are announced on a Ravenna system, and bridge that to Dante devices that can then read the sub-announcement and allow to connect to the AES67 stream. You can also show the SDP file with this tool. If you double-click on one of the entries, it opens this window, and you can even change data in here or put something else in there. So you can also, if you have an SDP file, you can just set up a new sub-announcement, and you put in manually the SDP data, and it makes a sub-announcement out of it. And by that, you can use Dante controller then to connect with devices that are in Dante AES67 mode. So that's quite a helpful tool. It's called RAF to ZAP. So if you Google that, you will find it. Troubleshooting. So what do I do if it does not work? Of course, first I check the stream configuration. And as I said, you have to check if the stream is actually AES67 compliant. Is it really within the mandatory spec? And if it's not in the mandatory set, does my device support it? Or maybe does it not support 96K, or does not support 9 channels, or whatever might be different there. Then check the configuration in terms of content. Is my multicast IP correct? Is the destination port correct? Check the payload ID, as I pointed out earlier. And also check the stream delay, because if I have a 1 millisecond packet time and the packet needs to travel the network, if I have a stream delay that is below 1 millisecond, the packet will be always too late. And some devices play it out anyway, giving a warning that it's too late, but it's playing. But some devices just drop the packet and they say, no, it's gone. I don't have to play it because the timestamp is already elapsed and I don't play it. So if you have no audio, that could also be a reason why this happens. If it still doesn't work, there's always Wireshark. That also looks a bit messy, but it's a really, really helpful tool. So if you mess with network, you should get acquainted with that because it's really helpful. And for instance, in this case, there's a sub announcement you can see here, and you can even read out the SDP file here as well. So Wireshark offers the possibility to parse that information and give it in a readable way, so you can check and troubleshoot what's going on in your network, what might be the issue why it does not work. For PTP troubleshooting, there's a tool from Meinberg, which is also very helpful. It's actually based on the engine of Wireshark, but it uses a different user interface to filter just out the stuff that is related to PTP. And it gives a very nice overview of the PTP infrastructure you have on your network. It shows you the grandmaster, it shows you the slaves, the boundary clocks. So if you set up a system and you start with setting up PTP, PTP track count is a very useful tool to check whether this is actually working, or if you have rogue grandmasters or maybe wrong clock domains, whatever might be the issue. You can see the packets and you can also inspect the packets in detail, but it also gives you a very nice human readable view, so to say, and insight in your network infrastructure. So let's have a at the end have a closer look at the configuration of AES67 with Dante AES67 devices. There are a few constraints when using devices in AES67 mode, Dante devices in AES67 mode. One thing is that they don't support unicast in this mode. Actually, that's not only Dante that does that. There are many devices out there that just skipped the unicast part of AES67. The reason, I guess, is that the market just didn't ask for it. There were no projects that really needed to have unicast in place. So many manufacturers just didn't bother to implement it. And also the part that SIP is mandatory if you want to do unicast might hold back the development there. So this is the case with Dante AES67 as well, but it's not really a big issue. You just have to know about that. What is a bit more an issue is the restricted multicast IP range that is used for Dante AES67 streams. There's a default prefix 23969 where the 69 is actually configurable, but it's fixed. So once you have set this number, all streams that are supposed to be run to the Dante AES67 device need to be in that multicast range. And there might be situations where you have a broadcast network where you just are not in the position to change that. There are many different, like 239, 40, 239, 48, 239, 100, whatever. So you really, if you do your planning of the multicast addresses and you have Dante AES67 devices involved, you really have to take care of this and think ahead that you put this together in a way where any streams that are supposed to go to the Dante device are in the multicast range that matches the prefix. The encoding is only 24-bit. That's not a really big deal because that's mainly what we want to use anyway. Packet time supported is basically the mandatory set for transmission. So it's 1 millisecond packet time, that's fine. For receiving, there's even more. It's 1 millisecond, but also 125 microseconds, 250 and 333. So there's a bit more options there for the receiving end. And then there's another thing which is can be dangerous if there's a lot of traffic on the network. The DSCP markings Dante uses in the AES67 implementations are not matching AES67. I will show you in a second on the next slide what can happen then. And just an informational note, the Dante redundancy mode is not available if the device runs in AES67 mode, but well, that's not a big deal normally. I just wanted to point this out, that this is the case. So if we set up AES67 streams between devices, what can be the pitfalls or the peculiarities? One thing is the SDP distribution. Not all devices allow to manually enter SDP data, so you might have to use a tool that makes a sub-announcement of it, or try other means to get the SDP information or the stream information back and forth between the devices. Then with Dante, there's the multicast prefix thing, which can be quite an issue if you have a bigger network where you are not free to design and to assign your multicast IP addresses. Dynamic payload IDs are something where you can just, it's a pitfall maybe. If some devices, I've come across implementations where the payload ID is set to a certain value, and it cannot be changed. And as it cannot be changed, the manufacturer does not really give that information in the user interface. So you just don't know it. They implemented something, and it works with their implementation because it's all the same. But if a third-party device comes into play, you realize, oh, I have everything set up, it works, but on multicast address, all is fine, but still I cannot connect. And then you realize, well, I'm missing this information. And sometimes then Wireshark is the only way to get that information to really find out what is the IP payload ID in this case. And then we have the DSCP markings I already mentioned. As a reminder, the standard specifies for clock packets, for PTP packets, EF and AF41 for media. Now, in the Dante AES67 implementation, the clock is CS7, which is even higher priority. That is fine. But the media is EF, and that actually clashes with the standard specification of AES67. So what could happen is, if you have an AES67 network with AES67 mandatory standard devices that use EF and AF41, and you add a Dante AES67 device, it will start streaming and it will interfere with the sync packets that end up in the same queue for the PTP. So this can degrade your PTP. And that is an issue you have to be really careful about. If you have a lot of data on the network and you have to use QoS, be careful with this. There are switches available that, for instance, remap those markings, so you can work around that, but you have to be aware of that and to configure the switches accordingly to clean this up. Just a last slide on the JTNM tested program, because these differences in implementations, the JTNM, EBU, and IRT joined to set up a JTNM tested program where the 2110 implementations were tested under certain conditions. The documentation and information is over there at that wall. Yeah, the idea was to find out what's the current status on the market and what devices with currently shipping firmwares are working together and really adhere to the standard. More information on jtnm.org or here on the show floor, and that's it so far. Questions?
Thank you, Claudio. We have time for one or two questions. Anybody wanted to get any more information about this? It really is a very important topic. I mean, getting all these different audio formats to work together is going to be absolutely key because there's so much installed base. So thank you very much. Any questions? Yeah, go ahead. Hold on a sec.
Does Dante run the same EF on their audio streams they're running in their own mode?
Sorry?
When Dante's running in a Dante network,
are
they running EF for quality of service on their audio?
For Dante, not AES67
Right.
things. I think so, but I'm not sure. I have to check that. So if questions come to your mind at a later time, you can always come by at our booth, DirectOut here in this hall, and we can have a chat there for too.
Okay. All right. Thank you very much.